question is, we have to evaluate the value of integration of this function x square plus 1 into x square plus 2 upon x square plus 3 into x square plus 4 with respect to x. Now to solve this question, first of all, on looking at this function, it contains the terms of square, and this makes this function very ugly, difficult to solve. Okay, but it is not that much difficult to solve, but it requires something to solve. Okay, now to solve this question, to begin with, first of all, we see that the numerator when multiply is going to give a biquadratic term, that is term of degree 4, and similarly the denominator is on multiplying is going to give an expression of degree 4 or a biquadratic expression. Okay, so first of all, we see that the degree of the numerator is equal to the degree of denominator, hence the fraction is an improper fraction. Okay, now we shall divide the numerator by the denominator. Okay, so first of all, what we do to divide is we multiply both these terms. So I get the numerator as x to the power of 4 plus 3x square plus 2. It is very simple to multiply x square, x to the power of 4, 2 into x square, 2x square, 1 into x square, so this gives me 3x square plus 2. Okay, and similarly I'm going to get x to the power of 4 plus 7x square plus 12. Now we begin the division process. We write denominator as divisor, the numerator as the dividend, and what we see here is that the first term of the dividend and the divisor both are equal. Okay, so what we have to do? We have to do nothing much. We have to just write 1 in the quotient, and multiplying with the divisor, I'm going to get x to the power of 4 plus 7x square plus 12. On subtracting, I'm going to get this as minus 4x square minus 10. So this is my remainder. So division completes here because the degree of the remainder is smaller than the degree of the divisor. So therefore, I can write the given fraction as equal to 1 minus, this minus sign is taken common, 4x square plus 10 upon x to the power of 4 plus 7 is x square plus 12. And this can be written as all the terms as it is, but the denominator is written in terms of factors. The factor came from the original fraction, and we write this as x square plus 3 into x square plus 4. Okay, so we shall resolve this fraction into its partial fraction. So resolving the fraction into its partial fraction, we are going to get this as equal to ax plus b upon x square plus 3 because it is a quadratic term, and similarly cx plus d upon x square plus 4 because x square plus 4 is again a quadratic term. Okay, next we have to take the LCM. So on taking LCM, I'm going to get this as ax plus b into x square plus 4 plus cx plus d into x square plus 3 upon x square plus 3 into x square plus 4. The denominators being equal cancel out. So I'm going to get this as 4x square plus 10 is equal to ax plus b into x square plus 4 plus cx plus d into x cube plus 3, which is my equation number 1. Okay. Now, calculations for the value of a, b, c, d. Now to calculate the value of a, b, c, d, we are left by no method but to solve it by coefficient comparison method. And for this question, the method of coefficient comparison is quite easy. If we solve by other method, that is by placing the values in equation number 1, it can become difficult. Okay, so nevertheless, I'm going to solve this equation by coefficient comparison method. Okay, so first of all, I'm going to multiply these, that is open this bracket by multiplying both these terms. So I'm going to get this as 4x squared plus 10 is equal to ax cube plus bx squared plus 4ax plus 4b. Similarly, cx cube plus dx squared plus 3cx plus 3d. Okay. Next, what I'm going to do, I'm going to write the term of same power of x together. So I'm going to get this as 4x squared plus 10, a plus cx cube, b plus dx square, 4a plus cx, and 4b plus 3d. Okay. Now, on comparing the power of x cube, I can write a plus c as equal to 0 because no term of x cube is there in the left hand side. Similarly, b plus d can be written as equal to 4. 4a plus 3c can be written as equal to 0. And 4b plus 3d can be written as equal to 10. Right? So we have these four equations. On solving these four equations, we will get the values of a, b, c, d. Okay. Now to begin with, I take these equations, a plus c is equal to 0 and 4a plus 3c equal to 0. And both these equations are equal to 0. So if you solve them, you will ultimately find that a is equal to 0 and c is equal to 0. You can do it for yourself. If you place c is equal to minus a from equation 1 into the equation 4a plus 3c is equal to 0, you are going to get c is equal to 0. And when c is equal to 0, so a will be equal to 0. So therefore, the equation will give a is equal to 0 and c is equal to 0. Taking equations b plus d is equal to 4 and 4b plus 3d as equal to 10. And to solve it, what I'm going to do, I'm going to write b is equal to 4 minus d. Okay, and I'm going to place or substitute the value in the equation 4b plus 3d is equal to 10. So I'm going to get 4 into 4 minus d plus 3d is equal to 10, or 16 minus 4d plus 3d is equal to 10. This will become minus d, and 16 is going to go here to give minus 6. So I'm going to get d is equal to 6. 6 can be written here or substituted here in the equation. So I get b is equal to 4 minus 6 or equal to minus 2. So I've solved a is equal to 0, b is equal to minus 2, c is equal to 0, d is equal to 6. Therefore, this fraction is resolved into its partial fraction as minus 2 upon x square plus 3 plus 6 upon x square plus 4, because a is 0 and c is 0. So the integration of this fraction can be written as equal to integration of 1 minus 4x square plus 10 upon x square plus 3 into x square plus 4 with respect to x. On substituting the value of partial fractions which we have resolved in this integral, we are going to get the expression like this, and this can be written as equal to three separate integrals, that is 1 dx, second will be 2 times integration of x square plus 3, and third will be minus 6 times integration of 1 upon x square plus 4 with respect to x. This minus sign when multiply will produce a plus term here, and minus sign inside when going to multiply inside the bracket will produce a minus term here. Okay, so now we can integrate all these three terms. So integration of x would be equal to 1 by 2 x square. Okay, it's very simple, so I think there is no need to explain. Now to integrate this term, I can write this term x square plus 3, or you can imagine in your head that this can be written as x square plus root 3 whole square. Okay, so this becomes the formula for integration of 1 upon x square plus a square, that is equal to 1 upon a tan inverse of x upon a. So this can be written as 2 into 1 upon root 3 tan inverse of x upon root 3, and similarly applying the same concept here, that is writing 4s equal to 2 square. So this fraction is going to be again solved to equal to tan inverse. So this will be written as minus 6 times 1 by 2 into tan inverse of x upon 2. So finally I'm going to get this as 1 by 2x square plus 2 by 3 tan inverse of x upon root 3. This 6 is going to cancel with 2, so I'm going to get this as minus 3 tan inverse of x upon 2 plus c. So this is my required answer. Thank you. Please support us by subscribing to our channel, by liking this video and giving your comment for the video.